chapter are we on in Core 1 Maths now?
I think it's chapter 11, Win.
Is that one of them? Is that the last chapter?
No, it's the last one, you're right.
Well, I'm going to have to put everything into it then.
Everything. Oh, gosh.
So, it's chapter 11 now from this
Integration.
book for the last time. Nice suit, by the way.
Oh, yeah, you too. Yeah.
Thank you.
That's good.
Gotta dress smart for these things.
Yeah.
So, it is the final chapter, and it's integration again, like chapter 10.
It is, but now we're actually using it. But what's it for?
It's actually for finding out the area under a graph between 2 points, or an estimation for the area under a curve. Because if you have, say, a straight line, and you want to find the area under it,
Just a
you
triangle.
just make a little triangle and then a rectangle, and you find the area, and that's easy.
That's really accurate, but you have something a bit more complicated, like a curve. It's quite hard to find the area under, say, that bit.
Yeah, I mean,
Between these points.
you could do a triangle, and that would be a terrible estimate.
That'd be a terrible estimate.
You could do tons of mini triangles and add them up, and that's sort of what you're doing with integration.
Sort of, yeah.
So, if we have the example y equals x squared, and you're said to find the area under the graph between the points 2, x equals 2, and x equals 6. So we know what x
Okay.
squared looks like.
Like that.
Like that, and you're looking between 2 and 6, you're looking for sort of that area there.
Yeah.
Now first you integrate it, and that's what chapter 10 was all about.
You don't know how to do that bit. Sort of, it's the reverse of differentiation.
Yes. Not to the degree if I don't know, it annoyed me so much when I did. So,
Sad times.
you integrate it, you're going to end up with a third x cubed plus c. But in the exam you often don't need to actually work out c, you just work with the differentiated bit.
You do.
That's by dx.
Now it gets a bit more complicated. You have to have super big, mega brackets, most of this.
Yes. In this case the bracket is only one thing, but normally you get x squared plus 2x plus 3 and it adds up.
Does that up.
So in this case it's nice and easy. You're looking between 6 and 2, and you denote this by putting a 6 at the top and a 2 at the bottom. And you do the top one first and the bottom one next, and you minus them. So what you end up with is you get square brackets, a third, and every x, in this case there's only one, but in every x is replaced by 6 first.
Yep.
6 cubed.
And then you minus the other one.
Yes, you do the whole thing again with the other one minus the 2. Just like that. But often, like we said, it's more than just x squared.
So it just gets a bit more
Often
complicated.
cubic as well, which makes it even worse. So you end up with these big brackets. They're often mark heavy because it's a non-calculator paper.
Yeah.
4 5 mark questions, so the big
Oh,
stuff here.
So then you just do it. So
Yeah.
6 power of 3 is...
I don't know. I know the
Quite a
answer
lot.
comes out, I think, at 63. The worked example's in the book, but I was just explaining how to do it. The actual maths, you can just type that in. A third of 6 cubed minus that, and you'll get an answer. Smack bang.
Not too complicated.
That's
It's
your
just to
answer
remember it.
of the area.
Yeah.
And that's all integration's for at Core 1. It's as hard as it gets. And
Which
so-
isn't too hard, because it's a new thing, they often make things a little easier.
yeah. So that's it at the minute. This will be your answer, 63 units. You don't have to put any units, you can just put 63
No?
area under the curve.
It might give you a unit of what the graph's measured in, and maybe then you might, but
Even then, it's very unlikely.
yeah.
Just do this, and that's that.
I think we should do a test yourself question.
Yeah, it's the best way to explain this. So let's get on with it.
Alright.
Harry.
Oh, Harry!
Harry.
Oh no!
Red wine, not rosé.
No, never rosé.
Harry,
Sorry about
oh,
this.
he's
We
dribbling and everything.
had a crazy party last night to celebrate the end of Cool One.
Yeah, a few people turned up. It's a small party, and that's why it's light now.
That's what it's like, yeah.
But he's here today for the
Yeah.
last time. Test yourself.
Oh, yes.
Question 2, page 152 from this legend.
Absolutely. Right. Okay, so I'll read it and you'll do it.
All right.
Okay, so question 2. The diagram shows the curve y equals x squared minus 4x plus 6. At the points P, minus 1 and 11, and Q, 4 and 6, and the line PQ. Part A says show the length of PQ is 5 root 2.
Okay.
So while we're waiting to talk you through this, I'm going to type down a diagram because it's kind of handy to have.
Yes. So this is chapter 1 stuff. This isn't a chapter 11 stuff. There's a line from P to Q, that point to that point. It's that length, and you've got to show it. So show that question. So it's just going to be a simple trigonometry. You find the upwards, the horizontal, and then the hypotenuse just by your usual Pythagoras. So in the x direction it goes from minus 1 to 4, which is 5 units across. So with Pythagoras that would be your 5 squared plus. Then it goes from 11 up to 6 units up, so that's 5 units down. So really that's minus 5, but squared it doesn't really make a difference, and that equals 50. So to find the hypotenuse you'd root that, root 50. And then we know by our third laws from chapter 2,
We do.
that's the same as root 25 root 2, which is the same as 5 root 2. So I've proved that. And that's
Very
question
nice.
1.
Okay, so part B says find the equation of the tangent to the curve at Q in the form y equals mx plus c. So like a normal straight line. So a tangent at point Q would look something like that. It would go across and sort of just touch that line.
And that looks like something we've done before.
It does.
To find the gradient at the point Q, you differentiate. It finds the gradient of the curve at that point. So you differentiate the equation of the curve.
That's what we need to do.
So, dy
So to
by
drive
x.
it, this year we times by the power and then we decrease the power by 1. So it becomes 2x minus 4 and the 6 disappears.
Now we know the point Q, that's the only point on the line we use,
We
so
do.
we have to insert that into here.
Yep, R4 and 6. Well, just R4 at this point.
Yep.
So it becomes 2 times 4, take away 4, which equals 4, which is our new gradient. Now we can do a bit of chapter 1 stuff, putting the gradient into our y equals mx plus c as it's m. So we've got our new coordinates in, so 6 equals 4 times 4, which is our x coordinate, plus c.
That equals
6 equals 16 plus c, so c must equal minus 10.
So just to put it in the final form, y equals 4x minus 10.
Absolutely. And this question hasn't had anything about integration yet, and that's what the chapter's about, so I'm thinking,
Part C is going to be integration.
that's what I reckon.
And it's just going to be the area under this curve, I can bet you
I
anything.
think it might be why I coloured it in.
Oh.
It is, find the area of the shaded region in the diagram, which is what I've coloured in, so it's between points 4 and minus 1.
It is. So the first step with integration is, unsurprisingly, to integrate the curve. So you have this elongated S.
Absolutely.
You add 1 to the power and then divide by it, so it becomes a third
X cubed, and the same in the next one, so it becomes minus 2x squared. Then plus 6x plus c. Now, for the ones you're working out area under the curve, you don't need to work out what the c is, but it's good to write it.
So we don't actually need it.
No?
So now we can do what we've done in this chapter, or what we spoke about in this chapter,
Yeah, we put in our two numbers, so we have the positive one first,
which is 4.
which is 4, and minus 1 second.
Then you do 2.
So two big square brackets, where we have the third of 4 cubed minus 2 times 4 squared plus 6 lots of 4. Take away all the same but with minus 1. So that's a third of minus 1 cubed. Take away 2 times minus 1 squared plus 6 times minus 1.
Yep, just like that.
So
next
we have
one.
to do all this. This bit does take a bit of time in the exam, and it's just mental arithmetic. These numbers are a little awkward, but they shouldn't be too bad in the exam. The only problem with an old book, which is quite an old book now, that it's still had a calculator when you had this, when this was first released.
Yes.
It's calculator paper.
Now there's not.
Now it's not, so it would be quite this complicating the exam.
So we've got 4 cubed is 64. A third of that is
20.
21 and a third.
Yeah.
I make it. That's 21 and a third. Minus 4 squared is 16 times 2 is 32.
Yep.
And then 6 times 4 is just 24. So that will be the first bracket.
It would, and then you minus the second bracket, so minus 1 cubed is minus 1 times a third is minus a third. Minus 2 lots of 1 minus 1 squared, which is 1. So it's minus 2 plus 6 lots of minus 1, which is minus 6.
So that makes the first bracket 21 and a third minus 32. Okay, 21 and a third plus 24 is
25,
45 and a third. Minus 32 is 8. 13 and a third.
13 and a third, yeah.
My pen is running out. I've got a blue pen.
I have got a blue pen. It's 13 and a third.
And that's minus. And then this is a minus.
This minus what we end up being plus.
Minus 8 and a
Yeah,
third.
yep, and that gives you,
You plus them together as Triv just said.
so gives you 21 and 2/3.
I make it there as well.
And that would be your area under this curve. That's not too complicated, but there it is, test sub question.
Yes, so I think it's time to say goodbye to this
Yeah.
book. Triv,
Yeah,
it's stone cold.
Oh, what should we do? Help, like,
CPR, CPR, CPR,
Wait,
CPR,
I
CPR,
don't think CPR's appropriate.
CPR.
He's dead.